Applications of work done by a force and a flux. I am Gladen Bizelpa, studying instrumentation at College of Engineering, and I belong to Devo section, semester 2, course titled Mathematics for CSE stream, and topic is application of work done by a force, flux. Introduction. A tornado picks up a couch and applies forces to the couch as the couch swings around the center. Work transfers an energy from the tornado to the couch, giving the couch its kinetic energy. When the object falls, gravity does work on the object. The work done by gravity converts potential energy to kinetic energy. Work done by a force. Work is the transfer of energy resulting from the application of a force on an object. When a force acts on a body and causes a displacement in the direction of the force, work is done mathematically. Work is given by the line integral, whereas W represents the work done and F represents the force vector, and D and S vector S refers is the differential displacement vector along the patch C. Examples: a tornado lifting a couch. The forces applied by the tornado causes work, transferring energy to the couch and giving it kinetic energy. Example 2. Gravity doing work on a falling object. The work done by gravity converts potential energy to kinetic energy. Flux. Flux refers to the flow of a quantity, such as fluid, heat, or electric field, through a surface. It is often represented by the dot product of a vector field and the surface normally. Mathematically, the flux hash pi through a surface S is given by pi is equal to slash int slash S math bf f, whereas math bf f is the vector field. D slash max bf S is the differential surface area vector. Applications of flux. Fluid dynamics, calculating the flow of fluid through a surface. Electromagnetism, determining the electric or magnetic field passing through a closed surface. Heat transfer, analyzing heat flow across a boundary. Work. In order for work to be done, three things are necessary. There must be an applied force. The force must act through a certain distance, called the displacement. The force must have a component along the displacement. Everyday types of forces. Other forces that commonly appear in the analysis of forces include applied force. An applied force is a force which is applied to an object by another object or by a person. Friction force, the force that resists the relative motion or tendency to such a motion of two bodies in contact. The work done by a force may be positive or negative. The work done by a force is positive if the force and displacement are in the same direction. The work done by a force is negative if the force and displacement are in the opposite directions. The work done by a force is zero if there is no displacement. The work done by a force is zero if the force is perpendicular to the displacement. Example, when we lift an object, the object moves upward in the direction of force. Here the work done is positive, but there is the force of gravity acting downward on the object. The work done by the force of gravity is negative. Example, a porter lifts a huge luggage of 15 kg from the ground and put it on his head, 1.5 meter above the ground. Calculate the work done by him on the luggage. Mass of luggage m is equal to 15 kg. Displacement is equal to 1.5 meter. Acceleration due to gravity is equal to 10 meter per second square minus square. Work done F is equal to m, and the mg is equal to s. 15 kg into 10 meter per second square into 1.5 meters is equal to 225 kg meter square. Examples of workflows include project management, software development life cycle, marketing campaigns, design projects, human resources tasks such as requirements, onboarding and performance evaluations, content creations, web page design, IT bug tracking. Work done by a force in physics. Work is done by a force only if the object on which the force is applied makes a displacement. Without this displacement, work done is zero irrespective of the following of the force applied. Work done by a force depends on the three parameters: A, the force applied, B, the displacement, and C, the angle between the line of force applied and the displacement. That's why when you apply a force by pushing a wall and it never moves, you have not done any work. In the terms of physics, we will discuss versions of equations of work done by force. We'll study a few cases of work done by a force as well. Positive work and negative applications of work done by a have conclusion of work done by a work difference, work done by a force, search work done by force. The work done by an object can be positive or negative. Since force F and displacement S are both vectors, the result of the work equation F is equal to F, S is equal to Fs or 0 depends on their directions. If F acts in the same direction as the motion, then positive work is being done. In this case, the object on which the force is applied gains energy. If the direction of motion and F are opposite, then negative work is being done. This means that energy is transferred in the opposite direction. For example, if you try to push a car uphill by applying a force up the slope by the car rolls down the hill, you are doing negative work on the car. Alternatively, the car is going positive work on you. Thank you.